So in section 4, we're going to start working with the primary objective for this chapter, which is multiplying, dividing, adding, and subtracting rational functions. When you look at this particular section, we're going to multiply and divide, which are essentially one kind of operation. So remember, we're working with fractions. Typically, in multiplying and dividing fractions, when you divide, you invert and then you multiply. So essentially, we're going to be multiplying this. The primary skill is multiplying, and division requires inverting the fraction that you are dividing by in order to then go ahead and multiply. Division is, of course, defined as multiplying by an inverse, so invert and multiply is the same thing as dividing. So key vocabulary here, you want simplified form of a rational expression, and a simplified form means that you have identified all of the factors that are in the numerator and the factors that are in the denominator, and you have canceled the common factors. So that's fully simplified, is when you have canceled all of the common factors. When you're talking about multiplying, you want to simplify before you multiply. It will make your life much, much simpler. So I'll be talking about that again later on. And then a reciprocal is an inverse. If I have A, its reciprocal is 1 over A. So when I say, if I'm going to divide by A, if I had something like B divided by A, that would be equal to B times 1 over A. These are the same thing. So now if A is a fraction, when I put 1 over it and reciprocate it, the denominator becomes the numerator, and the numerator becomes denominator. It essentially just flips over. So a type of problem I might use this for, so here again we have a company making packaging, and they've got this old packaging, and then they're going to do this new packaging, and they've decided that the new packaging is going to be the same bottom but twice as high. And we're going to talk about the surface area versus the volume, and we're going to look about how efficient it is. So we're going to create a ratio between the volume and the surface area. So how much surface area do you get for a certain amount of volume will have to do with efficiency. Depending on which I put in the numerator, then that will change how I evaluate efficiency as well. So when we talk about simplifying rational functions, this is what I talked about. The idea is that when I factor the numerator and factor the denominator, if I find a common factor, and a common factor means it occurs in both the numerator and the denominator. So when we say common, that's common to both the numerator and the denominator, then we can cancel them. Remember, factors are things that are being multiplied together. They are never things that are being added or subtracted. So if I've got a polynomial, for instance down here I have x squared minus x minus 20, I can't start canceling the x with this x. These are not factors. They are terms. I will need to factor these quadratics before I can start trying to simplify them. So the first thing you want to do is you want to take the numerator and the denominator and identify the factors. Now this is 4 times x times x. I'm being a little overly simple at this point in time because I want to be really explicit about what it is I'm factoring. I normally would never factor x squared into x times x. If I look at these guys, they have a common factor of 4x. So this is 4x times 5x minus 3. So now my factors here are 4x and the quantity 5x minus 3. But you see I have 4x here and I have 4x there, and when I'm done simplifying, this is fully simplified. Okay, if we look at these quadratics here, I would want to first factor the numerator. So factors of 20 that have a difference of 1, that would be 4 and 5. So this is x minus 5 times x plus 4. Now these are skills we learned in chapter 1. So if you still have difficulty factoring quadratics, I suggest you go back and start taking a look at some of the videos in chapter 1 that related to factoring. Okay, here I want factors of 15 that have a difference of 2. Well, that would be 5 and 3. So this is going to be, though, x plus 5, x minus 3. So you see, these are really close to the same, but they're not the same. So I don't actually have any factors that are common. So this is already fully simplified. Okay, now over here, if we look at this, okay, so I have x minus 4, that's a factor. There's nothing I can do to simplify that, but this is the difference of two cubes. This is x cubed minus 4 cubed. So that'll factor to be x minus 4 times x squared plus 4 times x plus 4 squared, which is 16. And then these guys cancel. So fully simplified would just be 1 over that. This would be the fully simplified version of that. Okay, so when you want to simplify a rational expression, factor the numerator, factor the denominator, and then cancel the common factors. That's how it's done. So go ahead and practice that. Do problems 14 through 16. When you're finished with that, come on back and we'll continue. So once we get to multiplying, when you look at multiplying, you're going to multiply the numerator times numerator and denominator times denominator. And what they've done here is they have multiplied it out, because this is a very simple rational function. They've multiplied it out and then they factored it. And what I would personally advise you to do is cancel the common factors. So for instance, what I'm talking about here is if I take the same problem, so I do not recommend that you do your work the way the book is showing doing this problem. What you want to do when you have two items being multiplied, I can cancel common factors across the two fractions. So for instance, 5 goes into 10 and leaves 2. The 2 goes into 6 and leaves 3. So this now is just 1y, but this 1y will cancel out one of those 3. These 2 y's will cancel out the remaining 2. This x will cancel that x. And now I've factored out everything I can do. I have 3 times x squared, which is 3x squared, over 2. So you see, by canceling, simplifying before I multiplied, I don't have to do this whole step of refactoring. So what they've done is they've multiplied first and then they've refactored, but this is already essentially in factored form. So by canceling first, I go directly to the finished answer. It saves a little time. Does it make any difference which method you choose? No. Both are valid, both are correct. I think this one is faster and simpler. But you can see that when you start canceling a bunch of things out, it also makes it complicated to make sure that you find all the things that haven't been canceled. Okay, so you don't want to make so much of a mess that it's difficult to find. So let's do some of these problems. Right? So 5 goes into 15 and leaves 3. 2 x's cancel out 2 of the 3 x's and leave 1. But this 1 will cancel with one of those 2 and leave 1. These 2 y's will cancel out 2 of those 3 and leave 1. So I end up with y times y, which is y squared, and 3 times x. So this becomes y squared over 3x. Relatively simple. Okay, same thing here. I have x minus 2 here and x minus 2 there. I have x here and x there. And when everything in the denominator is canceled, that means the whole denominator is now 1. So this just becomes x minus 3 times x plus 3. This is the way I really want you to give me your answers, in factored form. But you can see this also will make the difference of 2 squares. This is x squared minus 9. Both of these are correct, but I prefer that you give your answer in factored form. It helps me to figure out what exactly you did. Okay, so going on to, we have something a little more complicated. I want to factor the numerators and the denominators before I move on. So factors of 4 that have a difference of 3, 4 and 1. So this would be x plus 4 times x minus 1. This is factors of 4 that add up to be 4, 2 and 2. So this is actually the square of a binomial, x plus 2 times x plus 2 times, I can factor a 2x out of all of this. This is 2x times x plus 2. And I want factors of 3 that add up to be 4. This is x minus 3 times x minus 1. Okay, so again, I'm assuming you know how to factor from what we learned in chapter 1. If you still have difficulty with these things, we need to talk. Okay, so I have x minus 1 cancels with the x minus 1. This x plus 2 will cancel with that x plus 2. And those are all of my common factors. So I'll have 2 times x plus 4 over x plus 2 times x minus 3. Okay, this is my simplified form. Now, I hope you can see that if I had multiplied these together first, I would have gotten a 4th degree equation, and then factoring it would have been really hard. So you always want to factor and simplify before you multiply. So in a problem like this one here on the top, it doesn't really change much. But in a problem like this one here on the bottom, it's the difference between you being able to do it and you not being able to do it. So you always want to develop that habit. Simplify before you multiply. Okay, so now this looks a little different, but it's really not different, right? If I have an item that's not a fraction, I can view it as a numerator with a denominator of 1. I still want to factor the numerators and denominators. So I want factors of 10 that have a difference of 3. That's 5 and 2. X minus 5 times x plus 2. Factors of 15 that have a difference of 2. That's 5 and 3. So this is x minus 5 times x plus 3. That's just going to be 1. I want factors of 21 that add up to be 10, 3 and 7. So x plus 7 times x plus 3. And now I want to cancel common factors. So the x minus 5 and the x minus 5, x plus 3 and x plus 3. And what I end up with is x plus 2 times x plus 7. That's fully simplified. Okay, so go ahead and practice that on your own. Do problems 25, 27, 29, and 31. And come on back and we'll continue the lecture. So now we're going to talk about dividing. And remember, it's the same stuff. It's the same skill. The difference is when you take a look at dividing, you see if I'm dividing by, it's always by this item stays the same, and then what I'm dividing by is going to become inverted. So when I flip c divided by d over and invert it, it becomes d divided by c. And then I'm going to go ahead and multiply numerator times numerator and denominator times denominator. So when you're thinking of dividing, it isn't so much that we divide, it's just that we invert and then multiply. So the skill again is multiplying, but you have a step to do first. Okay, so this is an example of how that might go. And let's go ahead and look at some problems. So the first thing I want to do is invert. So I don't change anything about the first fraction, but it's going to become times y cubed over 30x y to the fourth. Okay, so now I want to start canceling common factors. The 5 goes into 30 and leaves 6. Okay, and you'll notice, what do I have in this problem? I have integers, coefficients, I have x's, and I have y's. I've done the integers, now I'm going to do the x's. Okay, so I have 2 x's in the numerator, and those will cancel with 2 of the 7, and this will become x to the 5th. I have 3 y's here, that'll cancel 3 of the 4 there and leave 1. And then this 1 will cancel with those 3, and that becomes 2. So now in the numerator, I just have y squared. And in the denominator, I have x to the 5th times 6x. So it's going to become 6, and the 5th times the 1st becomes x to the 6th. Fully simplified. Okay, so again, that's a very simple problem. I'm going to go ahead and divide, or factor and invert at the same time. Okay, so I want factors of 27 that have a difference of 6. That's 9 and 3. So it's x minus 9 times x plus 3. And I can factor a 2x out of each of these. 2x times x plus 1. Times, I'll have x squared in the numerator. That's easy. And then factors of 45 that add up to be 14. 5 and 9. Okay, so this is x minus 5 times x minus 9. And now I want to cancel common factors. Well, I have x minus 9, and I have x minus 9. I have an x here that will cancel with one of those two. And now I'm fully canceled. So I'm going to have x times x plus 3 in the numerator, divided by 2 times x plus 1 times x minus 5. So I have 2, I have x plus 1, and I have x minus 5. Now, sometimes you actually want to multiply this all out. For instance, it's possible, it's unlikely, but it's possible that by the time I multiply the 2 and all these things together, that x plus 3 might be a factor. It's unlikely, however. So it's something you should check. In this case, I'm not going to take the time to do it. Right? I know that this is going to become, if I multiply this together, I'm going to get minus 5x and plus 1x. That's going to be minus 4x. And when I multiply times 2, that's going to be minus 8. And 3 is not a factor of 8. So I can see now that it's not going to factor that way, and it's really unlikely that it would. But it's still something you should keep in the back of your head. You may need to check in order to fully simplify. Okay, this is a great problem because it's already factored for me. That's awesome. So I have x plus 3 times x minus 2 over x times x plus 1. So again, the first fraction, I don't change anything, times the inversion of the second fraction. I'm going to cancel x plus 3 with x plus 3. I have an x and an x. And it ends up just being x minus 2 over x plus 1. Okay, so that's how you go about doing this. Go ahead and get some practice. Oh, I got one more example. I'm sorry. So this is, again, what happens when I have, right, a denominator of 1. So when I invert this, it's going to be a little different. So I'm going to factor these and also do the inverting of the second fraction here all at the same time. So over here, it's going to be 1 in the numerator, and factors of 20 that have a difference of 1, that's 5 and 4, so this is x minus 5 times x plus 4. Factors of 15 that add up to be 8, 3 and 5, so this is x minus 3 times x minus 5. And then I can factor an x out of each of these, so it's x times x plus 4. And now we can start looking at what can we cancel. Well, I can cancel the x minus 5 and the x minus 5. And that's it. So I'm going to have x minus 3 times 1, which is just x minus 3, over x times x plus 4 times x plus 4, so that could just be x plus 4 squared. Okay, and that's fully simplified. So now go ahead and practice. Do 35, 37, 39, and 41. And then come on back so we can finish out the lecture. So here's our problem, right? And what we want to look at is we want to look at the surface area versus the volume for each tin. All right, so when we want to do that, then we want to calculate the ratio of surface area to volume. So that's going to be area to volume. Okay, and that means that if we're talking about surface area to volume, right, we want to have the least amount of surface area for the greatest amount of volume. That means that the smallest number is the most efficient. Okay, that's important to keep in the back of your head, because when you interpret this, you might be inclined with this problem to think that the higher number is more efficient, because that's typically how we do things. I personally, if I set the problem up, would put volume over surface area, because then the larger number would be the most efficient, but that is not what the problem told me to do. It said surface area to volume. That's numerator to denominator. Okay, so if I'm going to do tin number 1, so let's take this one. When I start thinking of surface area, the surface area of the bottom is S times S, and that's the same for the top. Okay, so I'll have 2 S squared. So actually, let me go ahead and write that very simply. 2S squared. That's the bottom and the top. And then I have 4 sides, and each side is S by H. So plus 4SH. Okay, and now I'm going to go ahead and factor that. because you can see that there's a 2s in each of these. So I'm going to have 2s times s plus 2h. Okay, so I have created the numerator and factored it. Now when we take a look at the volume, okay, the volume is going to be s times h. Okay, so s times h is going to be s squared h. Okay, so when you start looking at what can we cancel, I can cancel an s, and that's about it. So I'll have 2 times s plus 2h divided by sh. Okay, and that's for my first tin. So that's for, let's call this one A, and let's call this one B. So this one is A. Remember, I'm looking for the fraction that has the smaller value. Okay? So now when we do the same thing with this tin, I can see that, again, my bottom and top haven't changed. So in B, I have 2s squared plus I have 4 times s times 2h. So that's 4s times 2h. Okay, which is going to be 8, right? This is 8sh. Right? When I factor that, I can factor a 2s out of this. So that's 2s times s plus 4h. And then when we talk about the volume, it's going to be s times 2h. So it's going to be 2s squared h. So when we start canceling common factors, I cancel the 2's. I can cancel this s with that s. And so I end up getting s plus 4h all over sh. So my denominators are the same. But if I want to make a comparison of these, if I multiply this out, this becomes 2s plus 4h. Right? So if we're comparing the numerators, which numerator is bigger? Well, this numerator is bigger. Okay, so it actually creates a larger number than this one does. So B is more efficient. Now, some interesting things about this problem. When you first look at the problem and you start working it out, you should have realized, I certainly realized as I started into the problem, that I was not going to get a number for the efficiency of my tin. But instead what I did is I just kept working with the problem, and I eventually came up with an expression that was the efficiency of the tin. And then I got an expression for the second tin, and that allows me to compare the two expressions because they're expressions expressed in the same variables. So it makes it actually easy then to make the comparison. I can see I have s plus 4h here, but I have 2s plus 4h here, so it doesn't matter what value s is. This one is always going to be bigger. The side can't be a negative number. That's the only way this could become somehow smaller than that numerator. The smaller the number, the more efficient it is, and I've answered my question. So that's it for 5.4. You should be able to multiply and divide rational functions.